There we go.
Now here's a little science about climate change. But first, a little razzle-dazzle to go with the science. This is live footage from the International Space Shuttle. Okay, so it's not live, but this was a picture taken from the International Space Shuttle of a space station, of a sunset or a sunrise, something like that. But you can see how narrow the Earth's atmosphere really is. Now, back in the days before everybody had smart devices with flat screens, we had things called globes. Globes are spheres. They're models of the world. Did anybody here have a globe? Sure, some of you have seen globes. Now, I got a globe to pass out. Catch. Camera. Catch. Thank you. Future president of Chile over there. In joke on YouTube, you won't know a thing about what that means. Anyway, a globe, if you've ever touched one, has texture to it because they like to make it seem like they're representing the mountains on the land so you can see where the tall mountains are. You look from Mount Everest, and that's cool. You can feel it's taller. But none of that's real. That is way exaggerated. If you had a large, old-fashioned globe with a coat of varnish on it, back when we had real wood, varnish, like, paint, the varnish would be actually thicker than the real atmosphere. So know that that bright blue ball that is on Earth seen from space has a very fragile, very thin, fragile covering. But it serves us very important purposes, like it holds in the oxygen we breathe. But at the same time, it regulates the temperature of our planet. And I'm going to go through this pretty fast. So here it is. This is how global warming works. That's the sun, and that's the Earth. The sun is really much further away than it seems in this picture. But the ray of light from the sun hits the Earth and warms it. Most of the rays of light from the sun are absorbed by the Earth and warm the Earth. Some of the energy is radiated back into space in the form of infrared waves, which we can sort of feel as heat. But some of the outgoing radiation is trapped by the Earth's atmosphere and warms the Earth's atmosphere. The more carbon dioxide you have in the Earth's atmosphere, the more of this heat energy that started as sunlight, that got converted into infrared radiation, but just, that's the way the sun warms things, the more of that heat energy stays in the Earth's atmosphere. Actually, what happens too is these CO2 molecules, that's carbon dioxide, they start sort of wiggling more, so they get hotter themselves. And they store heat, and then when they cool off, they wiggle a little less, and they transfer the heat to the rest of the atmosphere. But I kind of like to think about these CO2 molecules wiggling as they absorb the heat that's normally would have gone out to space. All right, so Venus, obviously much hotter than Earth, closer to the sun than Earth. However, Venus has a bigger cloud around it of atmospheric climate warming gases, et cetera, et cetera. So that cloud is actually just more efficient at holding in the radiation that comes from the sun. Okay. So there's one more planet here. What's it called? Mercury, right? Now, Mercury, do you think it's going to be hotter or colder at its surface than Earth?
Hotter.
You think it's going to be hotter? Okay. So Earth is about 15 degrees Celsius. For those of us in the Fahrenheit world, 15 degrees Celsius is about 60 degrees. That's the average temperature on Earth. We can live with that. We can't exactly live with the 457 degrees C on Venus. But strangely enough, Mercury is a lot cooler than Venus. And one big reason for that is it's got a little atmosphere. It just doesn't have the coat to hold in the heat that's coming from the sun. So we can affect the temperature of our planet by affecting the size of our coat. We're building our coat bigger and bigger and bigger. We may not want to be doing that, as you will see. That's it for Division 3.